All right, guys, so we're going to go over a few more things. So one, I want to talk about what is a chemical symbol. So these are all chemical symbols here. An element is represented by what we call these things, right? A chemical symbol. When you look on the periodic table, they'll look similarly to this. A chemical symbol is identified by one capital letter and sometimes one lowercase letter. So here's your one capital letter, and then sometimes you'll end up getting like a lowercase letter like here. So in lead is P, capital P, lowercase b, and in calcium, capital C, lowercase a. And then nitrogen and uranium, you only have your one capital letter. You guys should be taking notes as you are doing this in your journal. So, what is represented by a capital symbol? Go ahead and take a second and jot this down in your notebook. The next question I want you to answer in your notebook is, what is the correct notation for a chemical symbol? How is a chemical symbol identified? So basically, you're going to look here and then tell me, how is it notified? The next one says, which chemical symbol is represented correctly? How do you know? So look at these options. You have A, that has a capital L, lowercase I, B, which has two capital letters, C, which has two lowercase letters, and then D, which has a capital NA, and then CL. Go ahead and tell me which is the correct chemical symbol, which one is correctly identified by a chemical symbol. And then don't forget to tell me, how do you know? Okay. All right. So now we've talked about elements. Let's talk about compounds. Okay. So we know that compounds are a pure substance as well, just like elements are a pure substance. But compounds contain two or more different elements chemically joined together. So they're different, and we know that they're chemically joined together. We talked about mixtures earlier, and we learned that mixtures are also elements that are joined together. However, mixtures can be separated easily, right? So compounds also contain two or more different atoms. So here is a great example. So you have the nitrogen atom, and then you have hydrogen atoms here as well. Here you only have carbon atoms. Same here. Here you have a carbon atom and a nitrogen atom, okay? So remember, compounds have two or more different atoms. So this right here, C2, this one right here is not a compound, right? It's an element or a molecule. So in your notebook, tell me, what are some characteristics of compounds? Now let's talk about compound breakdown. So compounds can be broken down into simpler substances, right? If you think about our lab, remember we broke down the sodium bicarbonate into carbon dioxide, right? And we broke down the ammonium chloride into ammonium and then into just chloride, right? So compounds can be broken down to each element it contains. And that is another example from our lab, right? If we go back to the calcium chloride, it broke down into a calcium as well as a chloride, right? Two chlorines. Compounds can be broken down into simpler substances. True or false? Answer this question in your notebook. The next question I want you guys to answer: what elements can H2O be broken down to? So what two elements are in this compound? So chemical formulas are two or more capital letters. So we like to look at it as compounds are represented by what we call a chemical formula. Just like elements are represented by a chemical symbol, like we just talked here, compounds are broken down using a chemical formula. Chemical formulas are identified by two or more capital letters. So here's a great example: nitrogen oxide. This is a compound, and you have your nitrogen and your oxygen, and it's represented, your chemical formula is NO. H2O, you have hydrogen bonded with oxygen. So you have two molecules of hydrogen and one molecule of oxygen. And here's your chemical formula for it. And it's also represented by two capital letters. Okay. So here are all some examples of some chemical formulas for you. The next question I have for you: which of the following best represents a chemical formula, and how do you know? So you have lithium, oxygen, phosphorus, and potassium oxide. All right. I want you guys to choose which one is a chemical formula and then tell me how you know it's a chemical formula. The next question I have for you is how many elements are in the compound calcium fluoride? How many elements are in this compound? And then how many elements are in the sulfuric acid? So how many elements are here in sulfuric acid? And here is the answer in case you didn't know. All right, so here, what atoms are in compounds calcium fluoride? So do you have calcium atoms only, fluorine atoms only, calcium and fluorine atoms, or neither calcium or fluorine atoms? Which one do you think is correct? All right, so now I want to move on to TEK 6.5b, which is basically talking about the elements that are inside of our Earth, that Earth is composed of. So I want you guys to pause the video and make the Fourier model for these 3 words. You've already done atmosphere last week, so now I want you to make a Fourier model for biosphere, hydrosphere, and lithosphere. All right, once you're done, let's talk about it. So the solid Earth, we call that the lithosphere. And the lithosphere is made up of a limited number of elements and is primarily composed of the elements oxygen and silicon. So you really have only these 2 elements that make up your solid part of the Earth, also known as your lithosphere. Earth's living matter is called the biosphere. So everything that is living, like us, animals, so forth and so on, we are all considered the biosphere. And it's made up of the limited number of elements and primarily comprises of oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. So you have all 6 of these elements that basically comprises of your biosphere. The next sphere that we want to talk about is your hydrosphere. So Earth's oceans are a part of your hydrosphere, and they are made of limited numbers of elements and primarily comprise oxygen and hydrogen, right? We know water is made of hydrogen and oxygen, so that one's kind of like a give you, right? And then the 2 elements are, of course, pure water. The atmosphere is made up of a limited number of elements and primarily comprises of nitrogen and oxygen, okay? So at this point, we've went over the lithosphere. The lithosphere, remember, is your solid Earth made of oxygen and silicon. Biosphere is composed of your Earth's living matter. And so that's oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. And then hydrosphere, which is the water. Hydro means water. Is Earth's oceans, and that's made of oxygen and hydrogen. Lastly, you have the atmosphere, right? That's how we breathe, right? That's nitrogen and oxygen, okay? All right, now I want you guys to complete the Abundant Elements interactive notebook, and I want you to glue that into your journals as well. Thank you.